Next thing now is what? This is the frictional force. Calculation in frictional what? Force. The first aspect I've done now is what? Is the theoretical part of frictional force. Let us look at what? Yeah, frictional force in a system. Frictional force in what? In a system. So the frictional force in a system can be determined by the following cases. I will give you like 7 cases. So the 7 cases you can use it to what? To solve any question in what? In a frictional what? Frictional force. So let me start from the what? From case one. Case one. So this case one is used to determine the frictional force on a rough horizontal plane. Once again, the case one here, we can use to what? To determine the frictional force on a what? On a rough horizontal plane. Please be sensitive this area. So let us start now. If this is a what? A plane, and this plane is what? Is a rough surface, and then we have a block that is rested on the what? On the plane. This is the block. So if the block is rested on the what? On the plane, so the weight of the block is acting what? Downward, which is W mg, and the reaction of the what? Of the block is acted what? Upward. This is what? R, which serve as what? Reaction of the block is R, is M what? Mg. The weight is acting downward, the reaction is what? Is acting what? Upward. So if I now apply a what? A force that's going to drag the what? The block along this side. The force that is I apply to drag the block along this side, then because this is the force is what? Is P. Let me call it P. And there is a particular force here, which is what? Oppose the, if I drag the block along this line with this P, definitely there is a particular what? Acceleration here, which moves the what? The body A. And here you will now have what? Frictional what? Force. It's opposed to what? Opposed the motion. But don't forget that what? This body that we are dealing with here is what? Is a rough, so what? Surface. So from this expression now, how are we going to what? To determine the the resultant force of applied force and a what? And a frictional what? Frictional force. If you check my previous video on the vector analysis, I've explained this before. That what? Two body, if two vectors are moved in different direction like this, if this one is A, this is B, I said resultant force will be A minus B, abi? But if two force A and what? B, they are moved along this direction, the same direction, the resultant force there will be what? A plus B. No be so? Let us apply it here too. So we are looking for what? Resultant force of applied force and a what? And a frictional force. This is the force used to drag the block. This one we oppose. Don't forget. So what will be the what? The resultant force. The resultant force now will be what? Resultant force, which is R what? F of this sketch will be what? RF applied force minus frictional force, because the body is what is moving along this direction. So you subtract frictional force from apply what? Apply force. This is the what? The formula for resultant what? Force there. Call it equation what? Equation 1. But again, you can say what? Where what? Resultant force, the net force, given as resultant force, will be equal to the what? MA. Mass times what? Acceleration. Want to know this acceleration? You can now put it A, you now have what? MA equal to the what? Applied force minus frictional what? Force. Divide through by M. You will have A equal to the what? Applied force, frictional force over what? Over M. This is the formula for acceleration of moving body. Call it what? Equation what? Equation 2. This is for what? Case what? Case 1. Can we solve question on this case 1 before we to the case 2? Let's solve 2 or more questions on it, please. Go to the what? Case 2. Now let us solve this question. Solution. We are given 2 force of 200 Newton. Pull a slag of a mass 50 kg. If you like, you can draw the diagram. This 200 Newton, they use it to what? To pull a what? A body of mass. What is mass? The mass of the body is what? Is 50 what? Kg. And force that apply to what? To pull it. What the force they apply to pull it? This force applied to pull it is what? 200 Newton on horizontal plane, which is rough. Overcome a constant frictional force of what? 40 Newton. So this 200 Newton is what? Is overcome a constant frictional force, which is what? 40 Newton. So the frictional force is what? 40 what? Newton. You can see that what the applied force, the frictional force. You are now asked that what is the acceleration of the what? Of the body. So the acceleration, assuming the body is what? It will be moving like this now. So the acceleration A is what? Is unknown. So you now apply what? This formula straight. So by applying the formula, what are you going to have? We have what? A should be equal to the what? Applied force P, frictional force over what? Mass of the body. Substitute for each value. Applied force is what? 200 Newton minus 40 Newton to give us over what? 50 kg. The applied force, here we have what? 1600 over what? 50 Newton. So it now give us what? 3.2 meter per seconds. That is the formula acceleration. So that's what? As a what? Acceleration. Let me help you to add one more question on this. So solution for this second question too. Solution. We have a force of 400 Newton. Pull a block of mass 50 kg despite a constant frictional force of 100 watts Newton acting between the block and the what and the ground. So for this case too, we have our horizontal what? Subhanallah. Our horizontal what? Plane. We have it like this. This horizontal plane, and we have this horizontal what? Plane. What is the weight of the block? Here is also what? 50 watts. 50 kg. Let me put what? 50 kg here. And the force used to pull the block is what? 400 Newton. The frictional force, which is opposite, is what? 100 what? Newton. So the frictional force is what? Which is opposed is 100 what? Newton. You are now asked to find the what? The acceleration of the moving block. This is greater than this, so the board will move like this. This will be the what? The acceleration A. So to know the acceleration A, we will apply the what? This equation what? Equation 2. We state that what? A is equal to what? What is the formula? Apply force minus frictional force, everything over what? Over M. You will now have A, substitute value. What is applied force? 400 Newton. Frictional force is 100, everything over what? 50. By subtract what? This, we have A should be equal to what? The A here, it will give us what? You have 300 Newton over what? 50 Newton. The A equal to what? 6 meter per what? Per second square. That's the final answer for what? For A. So the is two example for case what? Case 1. The next thing is what? Case 2. Let's check case 2. Case 2. Yes, this case 2 is absolutely different from the what for case 1. We are still maintain our what? Horizontal, rough horizontal plane. And I place a block of unknown mass. I place it here. This is the block that I place what? Here. And don't forget that the weight of the block acting downwards, the normal reaction acting what? Upward. So let me say this is the what? The weight of the block, mg. This will be what? The normal reaction m what? Mg. And this time around now, look at what? This case 1. The force apply that we use to pull the block or to drag the block is B in what? Horizontal to the what? To the floor. It's parallel to the what? To the horizontal floor. But this time around, the force here, it will not parallel to the horizontal floor. It will be in a what? In an inclined plane. The force here will be in a what? Inclined plane. Assume that what? The force that I apply to drag the what? The block is B along this plane. Along what? This plane. This is the force that is I apply here on the what? On the rope. So this is force what? P. This P is B on the what? On the rope. And the angle between what? This horizontal what? Plane. Here, let me put it here. This line, broken line, represents horizontal what? Plane. No? And here, the angle between this P and horizontal plane, let's call this what? Theta. So if we now, but before we can know the what? The resultant force, we must solve this P to be in what? In form of this. Because if you are dragging this block along this rope like this, the block will be moving. When block is what is moving, there is a particular force here which is opposed. The motion of the block is called frictional force, Abi. So before we can know our resultant force here, we must solve this to be in parallel with what? With frictional force under the solution of forces. So this P now, by the time we are resolving this P, it will give us what? P cos theta. Check it under the relation of vector. Whenever you are resolving for what? For horizontal axis, you have cos what? Cos theta. P cos theta. So this P cos theta serve as our applied force. This is what? Frictional what? Frictional force. So from this now, we can determine our resultant force here, which is what? P minus what? Fr. So resultant force will be what? And don't forget, sorry, the block is moving along this direction. Abi? So this will be the what? The direction of what? Of A, the block that is moving. So resultant force now, LF, will be equal to what? Is P minus FR. But our P here is what? P cos theta. Now what? P cos theta minus frictional what? Force. This is the formula for what? For resultant what? Resultant force. Yeah. So let me call this one what? For the case 2. Equation what? Equation 1. So in this case 2, you can change this FR to what? To MA. Abi now? To have what? MA is equal to the what? P cos what? Theta minus F what? FR. From this now, A equal to the what? P cos theta minus F what? R over what? Over M. So this is the what? The formula for acceleration where the force is inclined to the horizontal plane. When the force is what? Is parallel to the horizontal plane, there's no need for us to apply cos. Let us solve one question on this before we move to the what? To the next case. Let's solve this question. Yeah. Solution. It said a body of mass 15 kg is being dragged along the floor by the rope inclined at angle 60. Let's draw this diagram. The body of mass what? 15 kg. 15 kg is being dragged along the floor by the rope inclined at angle 60. So assume that what? This is the rope that we apply to drag the what? The block. What is the angle between the rope and the horizontal? So the angle between this rope and what? And horizontal, you can do it like this, is what? Is 60 degree. Is 60 degree. Abi? To stop. This is the rope. Oh. Don't forget that what this is what? A rope. This is what? A rope. The frictional force between the box and the floor is what? 150. Good. The frictional force between the block and the floor is what? Is 50. 50 what? Newton. Good. And the tension on the rope is 170. So on this rope, we have tension there that is applied is what? 170 Newton. Calculate the resultant force in a dragging block. What will be the resultant force now? The resultant force is what? P cos theta minus what? FR. Resultant force, what is P? 170 cos theta is what? 60. What is frictional force? Is 50. So we now have resultant force should be 170 Cos 60 is 0.5 minus 50. So the resultant force here, it will be what? This times this will have 85 minus 50. So you have what? The resultant force to be what? This will have 35 Newton. You can see that what in this question we are asked to find the resultant what force, not what acceleration. So how to find acceleration, you just put what m a equal to the what 35. You get your final what final answer. So the next thing that we are going to do now is what we are moving to the what case 3.